today we're going to be looking at specific heat capacity. Now the exam board is really limited on what they can ask you about it. I think there's three things they can ask you about it. Either its meaning, or calculation, which is the most likely, or what you should know is that the higher a specific heat capacity of a substance, the more energy it can store. So they could ask you about that for like sources of energy. Now, specific heat capacity is the amount of energy needed to increase the temperature of a 1 kilogram of a substance by 1 degree Celsius. Okay, and you need to know this definition. So amount of energy needed to increase the temperature of a substance which weighs 1 kilogram by 1 degree Celsius. And here's your equation, which they will give you in the exam. E is equal to M times C times delta theta. Okay, E is energy measured in joules. M is the mass of the thing measured in kilograms. The theta is the temperature, but what you should know and what you should always do is find the temperature change. Okay, the delta means change. In your exam, they will only give you the M times C times theta. But I usually like the delta in front of the theta because it reminds me that it's temperature change. And very few students actually work out the temperature change in a calculation. They just use one temperature that they give you, which is wrong. And that's measured in degrees Celsius. And here we have the specific heat capacity. Now the unit for this is very weird, but you should know it. Joules per kilogram degrees Celsius. Okay, because they might ask you about the unit in a calculation. Okay, specific heat capacity, joules per kilogram per degrees Celsius. So, here's a question. 500 joules of energy is used to heat 10 kilograms of a liquid from 16 degrees Celsius to 96 degrees Celsius. What is the specific heat capacity of the liquid? And I want you to give the unit. Okay? So, the first thing you do, let's write down the equation. E is equal to mc delta theta. Okay? Do we have the energy? Yes, 500 joules. Substitute in the values, we'll get a mark for that. Is equal to the mass. We have the mass? Yes, we do. 10 kilograms. Okay? Multiplied by specific heat capacity. Do we have that? No, we're trying to work that out. So that's the question mark. Okay? Do we have the temperature change? No, we have temperature at the start, temperature at the beginning. Temperature at the start, temperature at the end. Okay? So work out the temperature change. Not just use 96 degrees Celsius. No, do not just use 16 degrees Celsius. Work out the temperature change. So the temperature change is the difference between these two, which is obviously 80 degrees Celsius. Because 96 minus 16. Now you have to rearrange the equation to get the specific heat capacity. Okay? I'm not going to teach you how to do that, but I'm going to write down the rearrangement. So specific heat capacity is the energy over the mass multiplied by the temperature change. Do the mass multiplied by the temperature change first and then the energy divided by it. Not do energy divided by mass, then times by temperature change. You will get it wrong. Okay? Do this part first, then energy divided by it. So, 500 joules, 5,000 joules, sorry, divided by 10 kilograms multiplied by 80 degrees Celsius. So do this part first. So 10 times 80, that gives you 800. 5,000 divided by 800, I'm going to use a calculator. Okay, so it gives you 6.25. So your answer is 6.25. That will give you 3 marks out of 4 because it wants you to give the unit. So joules per kilogram degrees Celsius. That's your unit. Yeah, that's it. This has been the Awesome Tutor. Bye.